Welcome back to Max20. This video explains the solutions of GATE Mathematics 2018 exam. First question is, the principal value of minus 1 power minus 2i divided by pi is option A e square, option B e raised to 2i, option C e raised to minus 2i, option D e raised to minus 2. Let's check the answer. We need to find principal value of minus 1 power minus 2i divided by pi. First we know that e raised to I pi is minus 1. That is e raised to I pi equal to cos pi plus I sin pi. Cos pi is minus 1 and sin pi is 0. So e raised to I pi is minus 1. That is principal value of minus 1 is e raised to I pi. Now let's power minus 1 raised to minus 2i divided by pi on both sides. E raised to I pi raised to minus 2i divided by pi. We need to find the principal value of minus 1 raised to minus 2i divided by pi. So pi cancelled. What we get? E raised to I into minus 2i. I is I square, which is minus 1, and minus 2 is plus 2. That is, this is e raised to 2 or e square. So the answer is option A, e square. Second question. Let f from c to c be an entire function with f of 0 equal to 1, f of 1 is equal to 2, and f dash of 0 equal to 0. If there exists m greater than 0 such that modulus of f double dash of z is less than or equal to m for all z in C, then f of 2 is. We need to find the value of f of 2. We have given f is an entire function. F is entire function and some values of f. Also f double dash is bounded. This means f double dash is bounded for all z in C. So given f from C to C, entire function. This is entire function. So we know that if f is entire, then which implies f dash, f double dash, f triple dash, and so all its derivatives are entire functions. And also given that modulus of f double dash of z is less than or equal to capital M for all z in C. For all complex number z, modulus of f double dash is less than or equal to some m with m greater than 0, some positive number m. This means f double dash is bounded by a m, positive number m. F double dash is bounded. Also f double dash is entire function. We know that by Lively's theorem, bounded entire functions are always constant. So this means f double dash is constant. F double dash is constant function. That is, f double dash equal to some constant C. F double dash is C means f dash is equal to some linear function Cz plus D. By integrating f double dash, we get f dash is equal to Cz plus D. D is some arbitrary constant. C and D are arbitrary constants. Now we have given f dash of 0 equal to 0, which implies D equal to 0. F dash of 0 means C into 0 plus D. D equal to 0. Therefore, f dash is equal to Cz. Now integrating, f is equal to C, integrating z square by 2 plus an integrating constant, let's say C1. Now we have given f of 0 equal to 1 and f of 1 equal to 2. F of 0 equal to 1 means 1 equal to C1, that is C1 equal to 1. F of 1 equal to 2 means C by 2. Already we got C1 equal to 1 plus 1 equal to 2. So C by 2 equal to 1. 2 minus 1, 1. So C equal to 2. That is we get F equal to 2 into Z square by 2 plus 1. That is Z square plus 1. F of Z is Z square plus 1. Now we need to find F of 2. F of 2 is 2 square. 4 plus 1, that is 5. F of 2 equal to 5 is the right answer. So option B, 5 is the right answer. F of 2 equal to 5. Now question number 3. In the Lorentz series expansion of f of z equal to 1 by z into z minus 1, valid for mod z minus 1 greater than 1, the coefficient of 1 by z minus 1 is option A minus 2, option B minus 1, option C 0, option D 1. So given f of z equal to 1 by z into z minus 1 valid for mod z minus 1 greater than 1. The Lorentz series expansion of f valid for mod z minus 1 greater than 1. We need to find the coefficient of 1 by z minus 1. So given f of z equal to 1 by z into z minus 1 with the mod z minus 1 greater than 1. Now let's take the reciprocal. 1 by z minus 1 is less than 1. 1 by z minus 1 is less than 1. Now 1 by, write z as z minus 1 plus 1 and this z minus 1. Now taking z minus 1 outside, what we get? Z minus 1 plus 1. That is 1 by z minus 1, taking z minus 1 outside, z minus 1 all square, here 1 plus 1 by z minus 1, taking z minus 1 outside, z minus 1 all square, 1 plus 1 by z minus 1. So what do we get? 1 by z minus 1 whole square, and this is 1 by 1 plus z minus 1. 1 plus 1 by z minus 1. That is, we can write it as 1 by z minus 1 all square into 1 by 1 plus 1 by z minus 1. We know that 1 by 1 plus x is 1 minus x plus x square minus x cube, etc. So we can write it as 1 by z minus 1 whole square into 1 by 1 plus 1 by z minus 1 is, taking the expansion, 1 minus 1 by z minus 1. Here this expression is valid for mod x less than 1. So we get 1 by mod z minus 1. Sorry, mod z minus 1 is less than 1. So 1 by 1 plus 1 by mod z minus 1. 1 by mod z minus 1 is less than 1. So we can use this expansion. What we get? 1 minus 1 by z minus 1 plus 1 by z minus 1 whole square minus 1 by z minus 1 whole cube plus etc. So multiplying 1 by z minus 1 whole square inside, but we get 1 by z minus 1 whole square minus 1 by z minus 1 whole cube plus 1 by z minus 1 all raised to 4 minus 1 by z minus 1 all raised to 6 plus etc. So the coefficient of 1 by z minus 1. Question is asking about the coefficient of 1 by z minus 1. Here no terms of 1 by sigma z minus 1. This term, a series is starting with the term 1 by z minus 1 all square and all cube, all raised to 4, etc. The coefficient of 1 by z minus 1 is 0 here. So the answer is 0. So the answer is option C, 0. Coefficient of 1 by z minus 1 is 0. Now question number 4. Let x and y be metric spaces and let f from x to y be a continuous map for any subset S of x. Which of the following statements are true? Statement is true. Option A, if S is open, then f of S is open. Option B, if S is connected, then f of S is connected. Option C, if S is closed, then f of S is closed. Option D, if S is bounded, then f of S is bounded. We have given x and y are metric spaces and f from x to y be a continuous map. Given f from x to y is continuous. It's a continuous map. If the subset S of x, as a subset of x, is connected, we have the result continuous map maps to connected set to connected set. That is, f of s is connected. If s is connected, then f maps, f is a continuous map. F maps connected set to connected set. So if s is connected, then f of s is also connected. So option B is true. Now let's take f of x equal to c, means constant, arbitrary constant c. Now the subset S is equal to open 0, 1, which is an open set. Open set S is equal to open 0, 1. And x equal to y equal to r, the set of all real numbers. As clearly S is a subset of x. So S is an open subset of x. S equal to open 0, 1 is subset of R, and which is open. It's an open subset of x. So what is f of s? F is a continuous map and f is, we take it f as constant function. Constant function mapping open 0, 1 to constant c, which is the set C. F of s is set C. Only we get the constant c. So f of s is the set C, and which is closed. Which is closed in R, single tensor closed in R. So option A is false. Option A is false. Option B true, option A false. Now let's take f of x is equal to e raised to minus x. E raised to minus x, and take x equal to y equal to r, real numbers. And taking s is equal to closed to 0, infinity, which is closed in R. S is the subset of R and closed in R. What is f of s? F of s we get e raised to 0 is 1, e raised to minus infinity is 0. So finding the image we get open 0 and closed 1. E raised to 0 is 1 and e raised to infinity is minus infinity is 0. We get open 0, closed 1, but which is not closed in R. This is open 0 and closed 1, which is not closed in R. So option C is false. Now let's check option D. take f of x is equal to, let's take f from r to r, x and y equal to r. F of x is equal to 1 by x, the mapping 1 by x, and taking s is equal to open 0, 1, which is subset of R. What is f of s? Under the map 1 by x, open 0, 1 maps to open 1 infinity, which is not bounded, but s open 0, 1 is bounded subset of R. Open 0, 1 subset of R is bounded, but f of s is equal to open 1 infinity, not bounded. That is option D is false. So what we get? What we get? Option B. If s is connected, then f of s is connected. This is true. All other options are false. Next question, question number 5. The general solution of the differential equation x y dash equal to y plus root of x square plus y square for x greater than 0 is given by option A equal to ky square equal to x plus root of x square plus y square. Option B, kx square equal to x plus root of x square plus y square. Option C, kx square equal to y plus root of x square plus y square. Option D, ky square equal to y plus root of x square plus y square, where k is a arbitrary positive constant. We need to find the solution of this differential equation. X y dash is equal to y plus root of x square plus y square. Y dash is equal to y by x plus root of x square plus y square divided by x. This is homogeneous differential equation. First order homogeneous differential equation. Now let's put v equal to y by x. In order to solve homogeneous differential equation, put v equal to y by x. Or y equal to vx. What is y dash? V plus x into dv by dx. So what we get? Y dash, that is v plus x into dv by dx equal to y by x is v plus, taking this x inside the square root, we get x square divided by x square. That is square root of x square divided by x square 1 plus y square divided by x square is v square. So v cancel, but we get x into dv by dx is equal to square root of 1 plus v square. So dv divided by square root of 1 plus v square. Let's separate the variables, and dx divided by x. dv divided by root of 1 plus v square equal to dx divided by x. On integrating both sides, we get the answer. Integrating dv by root of 1 plus v square, integrating dx divided by x. We know that the result 1 by root of 1 plus x square is log x plus root 1 plus x square. Using the result, we get logarithm of modulus of v. Instead of x, we get v plus root of 1 plus v square. Using the result. And this is log x plus constant, we write it as log c. Now taking log v plus root of 1 plus v square minus taking log x this side and it's equal to log v. Log a minus log b is log a by b. That is log v plus root of 1 plus v square divided by x is equal to log c. Now v plus root 1 plus v square divided by x is equal to c. that is b plus root 1 plus v square equal to cx. b means y by x plus root of 1 plus y square by x square equal to cx, that is y plus root of x square plus y square all divided by x square. Root of x square is x, which we take this side c into cx into x is cx square. The arbitrary constant c we may take it kx square equal to y plus root of x square plus y square. That is our answer. So option C is the right answer. Kx square equal to y plus root of x square plus y square.